Okay, so we're doing a couple area problems here, and notice right away, because they're giving us left and right boundaries for these are what we call definite integrals, which means the answers that come out should be actual numbers. When these are done, we should be able to say 6 or 12 and a half. They won't have any x's in them because they're definite. We have values to plug in. Now, having said that, we don't cover this first one, so I will ask you to skip it. The reason being, you'd have to do the antiderivative of 1 over x, which we have not covered. It has to do with the natural logarithm, and so we'll leave it at that. This is not something we will ask you about, more about them later. I didn't learn these in grade 12 either. I didn't see them until first year university, and they're expecting you to not know it, so they cover it. You will be fine. The second one, though, is well within our power. This is the area under sine x, and there's always a dx there, and we're integrating from 0 up to pi. Now, if I sketch that real quick, here's 0. Sine starts off, rises, peaks at pi by 2, then drops, and pi is right where it hits the x-axis. So all of this is positive area. That means we should get a positive answer here and no problems at all. So all we have to do is our antiderivative. So what's the antiderivative of sine x? The derivative of cosine is negative sine. So the derivative of, if this were negative cosine, then its derivative would be positive sine. It looks like that's our thing. The antiderivative should be negative cosine x. So this should be negative cosine x, and we're evaluating that at pi and at 0 and subtracting the results. So first we get minus cosine pi. We plug in the upper bound, minus negative cosine 0. That's because we're doing here what we call f of b minus f of a. So antiderivative at the top end point, there it is, minus antiderivative at the lower left end point. So let's see if we can do all this trig here. We get minus, cosine pi is like cosine 180, it's negative 1, minus, and then we get negative, cosine 0 is actually 1. Da, da, da. All right, so what does this clean up to? Minus negative 1 is 1, and then we get minus negative 1, which is plus 1. So grand total of the area under here is 2. Now, you might remember from an earlier example, we found that anytime you have a sine or a cosine function, each half of this bump is 1 unit of area. So that's 1 unit. This is another 1 unit. We are not surprised to find that the total area under this complete bump is 2 units. We'll see that over and over when we do trig integrals.